This is continuation from where we ended. Now look at this, because we want to simplify it and make it be in the form of this. So we're going to be following where we want and how we want it to be. Now first thing is first. We have to factor out the terms. We have to factor out the constants. So we'll rewrite it the way it is again. We'll rewrite it. This is the same as exponent kx over k sine beta x minus beta k. Now I'm going to expand this. So this is the same as when I multiply this with that, I'll get k squared, this boy, cos beta x. Then look at this, negative times negative is positive, times this negative, it will be a negative, so this will be minus. Now b over k multiplied by b over k, so this will be b squared over k squared, then the integral of e kx sine bx. Now the first question comes in, what were we integrate? What did we integrate at the first to get to this point? We will realize that we were integrating the integral of ekx sine bx equal to ekx over kx sine bx minus b over k squared multiplied with ekx cos bx minus b squared over k squared, the integral of ekx sine bx. Now I want you to observe. Look at this and look at what we have at the end. It is a similar scenario. So we can give this, we can allocate any letter to this. You can allocate this whole thing to be m, you can allocate it to be d, you can allocate it to be, just make sure that you don't allocate it to k, because it might start confusing the answer. So you can allocate it to any letter of your choice. For me, I'll pick j. I'll say j is equal to ekx over k sine bx minus bk squared ekx cos beta x minus b squared over k squared. This will be multiplied by j. Now since this carries j and there is j this side, I can group the like terms. I can just add this term both sides so that it cancels out from here. So this is the same as j plus b squared over k squared j equal to ekx over k sine bx minus b over k squared ekx cos beta x. Now look, we have j here and we have j here. J at the first term and on the second term, so it means j can be factored out. So here we're going to remain with 1. This it is going to be beta squared over k squared equal to ekx over, on this side just write everything the way they are. You just have to write everything the way they are. Now look at this wonderful scenario we are having. So we know that j is equal to that, isn't it? We equated j equal to that. Now we can just take this whole thing to the other side so that we leave j alone. Now before taking it, look at 1 plus b squared over k. You can make k to be a fraction for 1 and for b squared. But how? So I'll say j, I'll open my bracket, I'll say 1 over k squared. So I'll say k squared divided by k squared is 1. 1 times b squared, that will be plus b squared. Now 1 divided by k squared is k squared. K squared multiplied by 1, that is what? K squared. Like this, equal to ekx over k sin bx minus bk squared ekx cos bx. Now we can take this guy to the other side by multiplying the function with the reciprocal of this. So we are multiplying the entirety of the function with k squared over k squared plus b squared. So this will cancel this side. So j will be equal to k squared over k plus bx ekx over k sin bx minus b over k squared ekx cos bx. Now from here you can start seeing our equation is coming out. You can start seeing it that it is coming out. Our answer is almost there. Now how do we move from here? The first thing we can do is we are seeing that sin bx has a k which is multiplying with it. Now look at this. If I were to multiply k squared throughout the whole function, k squared will cancel with this squared here, but 1k will cancel. I will remain with a k here. And if you see this, what it means is we can factor it out. Since this term has this term as ekx, the same for this, we can factor it out and just put it as a multiplier. So let's do that. Let's do that for this boy. So j is equal to ekx over k squared plus b squared. This is the first part. Then for this second part, 1k will cancel. We are going to remain with sin bx. Then minus. For this one, we're just going to remain with beta. Then cos bx. Now remember, now we just have to know for this. Since we were integrating, we integrated j, and j we know that it's that, isn't it? So we must add a plus c constant. But before adding a plus c constant, we should remember, let's come here. We were just integrating this, but we factored out the alpha. So we need to come and multiply this whole thing with the alpha. We'll multiply this whole thing with the alpha. Then we'll add an integrating constant. So when I multiply the whole function with alpha, I'm going to get exponent kx alpha over k squared plus beta squared, then k psi beta x minus beta cos beta x, then plus c. Now from here, that's where it gets interesting. Remember what we did. This whole thing now which we have is equivalent to this. Is equivalent to this here. Now, but if you look at this, it was equated to what? Y exponent to the power kx. So this is the same as it is equal to y exponent to the power kx. So now, looking at this, we can see that we are almost there. The only thing now which we need to do is to find c, the constant of integration. How do we find c? The question we are given that y is equal to 1 when x is equal to 0. we are going to use this statement. We're going to use this statement to find our constant of integration. Then everything will turn out the way it is. We see if we are going to prove. So let's go ahead and substitute 1 where there is y and 0 where there is x. So our equation was y, this bad boy, equal to alpha kx over k squared plus b squared k sin b squared minus b squared plus c. Now where there is y, we are going to put 1. Where there is x, we are going to put what? We are going to put 0. So this is more like 1 exponent 0 equal to alpha. This is exponent 0 over k squared plus beta squared. Now we have to ask ourselves a question. Sine 0 is 0 minus cos 0 here, it will be 1. So we are going to remain with beta here. Then plus c. So this time is 0, it's 0. This time is this, we are going to have something like this. And here we are going to have 1. So it's 1 equal to beta alpha over k squared plus b squared plus c. Now since we want to find c, we have to make c the subject of the formula. So c is the same as 1. Now we can see this, and here when we multiply this, we are going to get negative, because this is negative beta. So this is negative. So when you add it both sides, here to cancel, the other side it will be adding. So it will be plus beta alpha over k squared plus beta squared. Now from here you can see that we can try to make this as a denominator for 1 as well. We can make this as a denominator for 1. So for us to do that, we have to say over k squared plus beta squared. Now k squared plus beta squared divided by k squared plus beta squared, it's 1. Multiplied by the function on top, it's to be the same. Now 1 divided by this, it's k squared plus beta squared. Multiplied by 1, we are going to have k squared plus beta squared. Now this is our c. This what we have found here is our c, and we are going to substitute it where there is c in our equation. So y exponent kx is equal to alpha ekx over k squared plus b squared, k sin beta x minus beta cos beta x plus, now instead of writing plus c, I'm writing plus this whole thing. So I'll say open bracket k squared plus beta squared plus beta alpha, then I'll close my bracket, then over k squared plus beta squared. Now look at this. Let's look at what they are telling us to find. We can try to compare now, because now things are coming out. We can try to compare. Look, they want us to make something. They want us to make something similar. Yeah, they want us to make something which will look like this. If you try to look here, there is no e to the power kx, but here there is e to the power negative kx, which means it's 1 over e to the power kx. Now let's try to see how we can manipulate our answer here. Since we're having e to the power kx here and e to the power kx here, but to our term here, there's no e to the power kx. So if you can divide throughout the equation with e to the power x, it will cancel here, but here it will divide, which is just the same as e to the power negative kx. So that's how it comes out. So this will be alpha over k squared plus beta squared, like this. Then k sine beta x minus b cos beta x plus k squared plus beta squared plus beta alpha over k squared plus beta squared, like this. Then this is all divided by, we can say it is being multiplied by 1 over ekx. Now if you try to look at this 1 over ekx is the same as just making the power a negative when it goes on top. So now finally we can write it as alpha k squared plus beta squared, then k sine beta x minus b cos beta x plus k squared plus beta squared plus alpha beta plus k squared plus b squared, of which we have hence, it is hence shown. So we have managed to show that the ordinary differential equation we had is equivalent to this. Thank you for watching, and please, if you haven't yet subscribed to our channel, we kindly ask that you will, so that you don't miss out on future endeavors. Bye bye.